Hello, SAP community. This is week 3, session 3 of ABAP Mondays of October 1st, 2025. We had 2 wonderful sessions earlier, and I'm sure you're looking forward for this one. As always, you can post your questions in the chat, and our expert speakers will address the question. Topic for today's session is evolving data integration with SQL services and CDS external entities. The speakers of today's session are Leon Stern and Yannick Rath. Welcome, Leon and Yannick, and over to you.
Thank you for the introduction. So my name is Yannick Rath. I'm one of the developers for the CDS external entities, and I will present the new features we developed so far for the CDS external entities. Now to you, Leon.
Yeah, thank you, Yannick. Welcome also from my side. My name is Leon Stern, and I'm a developer in the area of SQL services. And yes, I will speak to you in the second part of this session. But first, let's see what Yannick has to show. With that, back to you, Yannick.
Oh, thank you, Leon. So welcome to today's session about evolving data integration with SQL services and CDS external entities. First, let me start with a short recap about what are external entities. So an external entities are a CDS object type with the aim to access data from a remote data source within the AS ABAP and make it available in the CDS infrastructure. So, and the remote data source are primarily a HANA or non-HANA database system, and as such, external entities are objects that cross system boundaries. So what do we need? For the design part, we have like our CDS external entity, the logical external schema, which is used for remote database schema. We have the outbound service where we will define that we use outbound SQL access to talk to the remote system. And then we have the communication scenario, which we need to tell that which outbound service we will need. And this communication scenario is used at configuration time by the administrator in the communication arrangement app, where you can fill out all the necessary data that is needed to connect to the remote database, for example, user and password, or even certificates if you are able to use PSEs. So if you are more into pictures, you can see that we have our external entity, we have our external schema, and the communication arrangement. If everything together, we are able to execute like a query, select from my external entity provided by logical external schema into the data in the ABAP SQL. Without that, we could still write it, but we will not get any data. So what did we do as the first milestone? Not only reading data is important, but also writing data. So for this, I will just talk about our new approach, how to write with external entities into the remote database system. So first of all, we have the new keyword writable in the definition of the external entity. It's similar to the writable of a view entity. So what will we do with it? So with the writable statement, we support the following ABAP SQL statements. First of all, the insert, to insert new data sets, the update, to update a current data set, then the modify, to modify data set, and of course, we will be able to delete. So the HANA does not support a two-phase commit protocol. This is why we have a dedicated service connection for each logical external schema. As you remember, a logical external schema is needed to access the data because it holds like the remote source to the remote database. And in order to insert, update, modify, or delete something in an external entity, we have to create a dedicated connection where we put in our logical external schema, and in the SQL statement, we also have to provide the connection and also have to commit our connection. Without the commit part, nothing will happen so far. So, and with the writable, we also added some more rules. So the first rule is our dedicated connection. We always need it. You always have to provide it with the dedicated connection. We have a separate commit and rollback from other connections. So each connection is only for one LES. And so we have one commit for each LES. And our external entities definition have to be the same key fields. This means that we even need a key field at least once in our remote database. Also, they have to be identical. So we have to include every key field. It has to be the same structure like the remote table or the remote view. And we have to consume all fields from the remote object that cannot be null. Even though if they have a default value or something, we still have to consume it because we just not transfer the default value to the external entities. So now I will just show a quick demo about how to use them. So for that case, my good friend Bernd, who works as an agent, had asked for my help because his job is to infiltrate the DevTober service team. And for that, with his help, I was able to create the following DevTober service external entity, where we have like a tent ID, service ID, and there's all matches the data in the remote system. And I want to register him as a new server so that he can work as a service member in the DevTober. And for that, I have like a little class program where first of all, I will do a select on the external entity to see that he's really not in there yet. And for that, we can already see that there's only service ID server 1, 2, and 3 is in there. So let me create a new entry for him. So I have to create my connection. As you can see, I will insert a logical external schema, the ZDSD DevTober write. And I will create a data record for him. So like with the service ID I provided before, which is 007. And so right now, I will insert a new record using the insert statement provided with the connection part. And now we executed the insert statement, but when I just select from the data set, okay, we can still see there's no data record in the remote database. So once I committed and select again, we can see that we created a new entry for my good friend Bernd, and he can do his work. And because I helped him, I will order a beer now from him. And to do that, I just need my connection again. And I will update this beer salt part to beer salt +1. And once I successfully committed my connection and select again, the beer salt counter will go up 1. And in this way, we can do it like the same with the modify or delete and work analog. So that's how we support Writable. It's just important to have the Writable part and that the external entity is provided at one time. So now we have the next big feature, the static external entities or external entity with static access. So our primary goal is to integrate external entities into the CDS stack. But right now, we are not able to build a view entity on top on a dynamic external entity. So what did we do? What is the solution? Exactly the static external entity. With that, we are able to define a view on top on an external entity. So what is the difference? So the main difference is that a static external entity is not provided at runtime, but provided by a logical external schema directly. So it's already in the data definition. So, and this also allows that we can define DCLs, which we cannot do in the dynamic. And of course, what I just said, it's important that we can use it in a from clause right now. And so far, we do not support Writable for the static external entities. So from the dictionary point of view, the activation of the static external entities is independent of the remote objects. So we have two cases. We activate a static external entity with a configured remote object on a data source or not. So if the connection is not working, we just have a default fallback and we just get an error when you select from it. But if the remote object is configured, then there could be a few things. For example, we could have a remote object that is missing, that is unavailable, unusable, or whatever, but the activation itself will still succeed if the external entity does not have any dictionary problems. And for this case, we write some logs into our dictionary log, which can be seen later in the demo again, because imagine if we transport a static external entity and the target system does not have a configuration ready yet, we don't want any errors to be happen there. And now, for the last part, I will just show some more support enhancement for the data type we did. So the first one, in our CDS family, we have our simple type. And the simple type is just a type definition that can be used to declare a field, an external entity. And the simple type can also be an enum. And we just support that if we have on the remote database a small int, can also be an enum in our CDS external entity. Then we all know that ABAP does not support a real Boolean. We have our beloved ABAP Boolean, which is an ABAP.char1. But the remote database can have a real Boolean. For that, we have a mapping to an ABAP char1. For example, like if it's true, we map it to an X. And if it's false, we map it to a space. And the HANA also does support decimals with really great precision. And for that case, we map it to an ABAP deck float 34. And this will happen with a 2-decimal cast. So everything that I just talked about, I will show in the demo again. So first of all, I have a static external entity, which can be seen that this was federate data provided by an LES directly, and I can just use it in normal SQL syntax, like you are used to if you are already a select from a view. You can just write it this way without the provided by, because it's already in the external entity part. Now, also, what is possible that I have now a view entity that's using an external entity in the from clause. And also we are allowed to make associations. So in this case, I have two associations, one to a view, which is on top of an external entity as well, and one to an external entity directly. And I can use the fields in a result and I can see them. So for example, the value from the external entity, which is this one, and from the view on the external entity are obviously the same. And with this, you are able to build view entities with joins to different systems with the external entities, but always keep in mind that the more complex the joins will get, it could result into a very, very long running time. So we do not recommend it, but you are able to join as many different database systems as you want. So, and now it's about the data enhancement type. So first of all, that I have like my simple type, which is just an enum to ABAP into enum. So where I map default to initial, foo to 5, and bar to 10. And when we select from the external entity, we just see that we have like a real Boolean on the database system. And when it's true, we get an X. When it's false, we get in space. And then we get the foo and the bar instead of 5 and 10. And it's the same as it just works. And if we take a look in our protocol, we can see that for the Boolean part, we have a case that when true, then X, and when false, then space, and as we return null. And this is by default if the remote column is in Boolean, and the same for the decimal that we see. And at the end, I just want to show how does it look like when the remote object is not usable. So for this case, I have like an external entity with an error. And if we go to our dictionary log, we can see that the attribute HANA data type for ABAP column beer sort is not compatible with remote big into inner. So I am still able to activate it. I'm able to build a view on top. I'm able to use it. But once I execute it and try to receive the data, the static external entity, I get an unlinked view that is not usable, and I will get not any data. And that is still unlinked and it's not usable. And with that, that's our newest feature for our external entities. And I will hand over to Leon.
Yes, great. Thank you, Yannick. Let me quickly get the sharing. So yeah, after Yannick's great demo of CDS external entities for federated data consumption in ABAP, I would like to flip the perspective and talk about exposing data from an ABAP system. So in this part of the session, we will dive into SQL services, a technology that enables reliable and controlled integration of ABAP-managed data, not just with other SAP solutions, but also with non-SAP applications. Just to keep things fresh and to avoid repeating too much from last year's session, I will start with a quick recap and then focus on the demo to show you the new features we have added since then. And I will also explain how CDS external entities and SQL services can work together for a powerful ABAP to ABAP data integration. So, but before we get into all the details, here's a quick summary to start with. So as I told you right now, SQL services are the solution for reliable and controlled integration of ABAP-managed data based on SQL. They are built on the familiar ABAP Cloud service model. So they are using service definitions and service bindings, and they open up the door to ABAP data through standardized interfaces, namely ODBC and SQL. By that, they fully respect ABAP concepts like access controls and table buffering. On the client side, any application that supports ODBC and SQL can connect, making SQL services extremely flexible for all kinds of integration scenarios. To make the things a bit clearer, this slide will show you what's needed for a working SQL service. So first, the developer models the CDS data model, if it's not there already. Then with a service definition, they describe the external interface, so to say, for that model. And with the SQL service binding, this interface is finally made available via SQL and ODBC. Of course, as always, we need some configuration, which mainly means the authorization and all the user stuff. But to keep it compact, we will focus on the developer side today and assume that we have an admin, which is handling all the configuration stuff for us. And if you are interested in the configuration part, I highly recommend to check out the documentation for that. So finally, when an SQL request comes in, then it's processed by the SQL service runtime on the ABAP application server. And this means the SQL statement behaves just if it were run from an ABAP program, so that all ABAP concepts are applied. And that is really the key takeaway here. So the SQL isn't executed directly on the database, but it's handled by the SQL service runtime in the ABAP application server, like we know it from ABAP SQL, for example. But why not just access the database of the ABAP system directly? Yes, you might have heard already, direct database access is strongly discouraged, but why is it? Yeah, there are both technical and architectural reasons, and just to mention a few here. From a technical point of view, you might not even have access to the database. Just think about SAP-managed cloud systems, for example. In addition, it's very risky to use the database objects managed by the ABAP system, since their life cycle and implementation is completely controlled by ABAP and the data dictionary. An example to mention here is the special handling of currency fields or the use of ABAP-managed database procedures. Other important points or other important ABAP concepts bypassed are the client handling, the handling of access controls, or the table buffer. And especially the table buffer invalidation becomes really important when starting to write to ABAP-managed data from external applications, because we need a table buffer invalidation to have the data consistently integrated with consumers in ABAP. On the other hand, from an architectural point of view, the service definitions used are a great construct to create a stable API for the data model. And especially the use of alias names help to abstract array internal names and allow some decoupling at this point. To summarize, in short, SQL services give you a clean, safe way to access ABAP-managed data based on SQL, but without all the pitfalls of direct database access. With SQL services, you can imagine the whole ABAP system as the database itself. Another important point I would like to highlight here is the flexibility of SQL services, because thanks to the use of ODBC and SQL, which are standardized interfaces, you can integrate a huge variety of applications and programming languages. So the application just need to support ODBC, and you need a client where you can install the ODBC driver for ABAP, of course. So that's the first integration scenario, so to say. If we look around in the SAP family, then SQL services also enable the integration with SAP HANA using HANA Smart Data Access. And this lets SAP HANA, and this means SAP HANA Cloud and SAP HANA On-Premise, run federated queries on ABAP-managed data. And now, by knowing this, we can actually close the circle back to CDS external entities, because they are using the HANA SDA technology under the hood. And this means we can build an ABAP to ABAP data integration by combining CDS external entities with SQL services. To make this more specific, on the consumer side, we then have a CDS external entity, which basically points to an SQL service on the provider side. And the SQL service is then accessed via HANA SDA, and on HANA SDA level, they are using the ODBC driver for ABAP to access the provider ABAP system. So not only ABAP to non-ABAP and non-ABAP to ABAP integration is possible, we can also integrate ABAP to ABAP by combining both technologies shown today. As I've mentioned the ODBC driver for ABAP a few times already, I also want to provide some details on it. So it's basically the client-side piece you need to access SQL services. And it's the key component that makes all this flexibility with SQL services possible, as it provides the standardized ODBC interface. Just a few technical facts about a driver. yeah, it currently implements the ODBC 3.5 standard, and it's a shared library written in C, C++. And yeah, it's there to handle the communication between the consumer application and the ABAP system. And for that, it is using WebSocket-based RFC, but that's just a technical detail. Where can you get it? You can get a driver from the SAP Software Center, and it's currently available as a 64-bit version for Windows, Linux, and Linux PowerPC Little Endian. And for the HANA SDA scenario, it's pre-installed on SAP HANA Cloud instances. For SAP HANA on-premise, you need to install it manually. Okay, what's missing now to access the data? Sure, we need some SQL statement. To give you an overview about the current capabilities, I listed them here on this slide, and they are basically select and call for retrieving data, insert and delete for adding or removing records, and we support the creation and dropping of temporary tables, which can be used for table input parameters in call statements. We will see this in a moment. Of course, you might expect now the update statement along with insert and delete. And yes, you are completely sure. Currently, it's not supported, but the update statement is planned for an upcoming release. Just to let you know that. So now, before we finally start with the demo, one last topic. It's about access modes of SQL services. Because depending on your integration scenario, there's a distinction between business user access and technical user access. With business user access, the SQL service endpoint created by the service binding gives access to this specific SQL service. That's why it's also called single schema access. And in this mode, for the business user access, all the CDS access controls defined on CDS entities are applied, just like in ABAP SQL as well, based on the permissions of the current end user. So this makes this mode ideal for end user applications where users directly authenticate directly with the ABAP system. On the other hand, we have technical user access, which uses a system-wide global SQL endpoint to access all SQL services available in the system. And in that case, the CDS access controls aren't applied. And that is why it's also called privileged access. Instead of the CDS access controls, there are special authorization objects on CDS entity level. So the technical user either has access to all data in a view entity or no access at all. Yeah, as the name of this mode already suggests, it is for technical data integration scenarios like system-to-system communication, where the consumer side of the data enforces the needed end-user permissions itself. The difference between the two modes is reflected in the service path. So you either address a single SQL service in the business user access case, or you address the privileged access endpoint to access all services available in the system. Of course, only if you have the right authorizations in place. For the manipulating statements, insert and delete, which are supported currently, only the privileged access mode is supported right now. Having said this, let's move on to the demo and see how this works in a real system. For that, let me open up ADT. So it's still rescaling. Now it's there. Fine. So as mentioned in the presentation part already, everything starts with the CDS data model. For this demo, I will keep it very simple and focus on a single entity. And it represents some Devtoberfest orders, and it's very similar to Yannick's model actually. So each order basically includes a number of beers and a number of food items. Our goal is now to make this entity available, readable and writable by an external application through an SQL service. And to achieve this, we create a writable CDS view entity on top of the table entity. And for now, this extra layer is needed because it's currently not supported to directly expose a CDS table entity in a service definition. This will change in a future release, but even then, if the extra layer isn't required anymore, it may be useful for abstraction because by using a view, it's possible to use alias name on field level. And this decouples a bit from the internal names of the data model. However, the key is now to use a writable entity just to allow data changes beside of data reads. Yeah, and that's it already. Our data model is ready. And the next step is then to create a service definition where we include our writable view entity. Yes, so for now, we concentrate on the first line here. It's our writable view entity. And at this point, it's again a good idea to assign an alias name just to keep things flexible and decoupled from internal names. We will come back later and see what's about the second line here. Based on this service definition, we now create a service binding of type SQL, as you can see here. So binding type is SQL. And we then select the needed operations on this service. So in our case, we would like to allow select, insert, delete, and execute, as we will expose a procedure later. But as I said, we will come back for that. So from a development perspective, the last step is now to create the communication scenario, which defines the necessary authorizations for using our scenario, so to say. So as you can see, I just specified still loading. I just specified the pre-installed privileged SQL service endpoint. And in the authorizations tab, I defined authorizations for the object as SQL view. And I basically defined that we need select, insert, and delete for all views in our SQL service. So in that case, I used a wildcard, but we could also use a specific list in this case for SQL view here. So from a development perspective, that's it. The rest of the configuration, so I mean user creation, user role assignment, and so on, is handled by the administrator. So as I told you, we won't focus on that today. Okay, then let's try if we can retrieve the data from an external application. But first, just to prove that there is data already in, let's use the ADT preview first. And it's, yeah, there it is. 30 records are retrieved. It's exactly the data I prepared before this session. So let's check if it's available from an external application as well. As I mentioned earlier, ODBC and SQL in combination opens up a lot of possibilities. For example, we can now use Microsoft Excel to read the data from the ABAP system. And for that, we just connecting by ODBC data source. Still loading. There it is. Here we can select the data source name. I will give you some details on that in a moment. And now Excel is fetching some metadata and shows up the available schemas and the available entities in these schemas. You will see this in a second. It's very slow today. Not sure why. So there it is. So we can see our SQL service is listed here. It's this one. And within our SQL service, we can see that there is one entity. It's our order entity. And if I now click on load, Excel will fetch all the data from the ABAP system. And after some processing, we will see all the data listed here in this Excel sheet. So 30 records retrieved exactly as in the ADT preview. For sure, normally there would be now some authentication needed, but in my case, Excel already cached the credentials from a previous attempt I did. So you may have noticed that we had to select a data source, and this needs to be configured in the ODBC Data Source Administrator application in Windows. In our case, it's the data source with name Z08. And here you enter all the connection details like host name, port, and service path. And as you can see, I'm using the privileged SQL endpoint for the demo. So actually, reading data via SQL services has already been supported. So that was just a recap. What's new is the possibility to insert and delete data. And as Excel cannot insert or delete data, at least I'm not aware of this, I will show you another way to use ODBC. And for that, I've built a simple C#.NET application as an example on how any application can be integrated. So first, I just start the application to see what it offers. So it offers three options. First one is create order, second one is delete order, and the third one is summarize result. But let's start with the first two options. So first, I would like to create an order. So that I'm choosing option 1. And let's say I would like to order 3 beers and 2 food items, for example. And after I confirm the order creation, the application now inserts the row to our order entity. And as we can select the data via Excel, we can verify in Excel by refreshing the data here. Just click refresh. And yep, there it is. Our newly created order appears in Excel. Okay, so with that, we created an order, deleting an order. So the second option in my console application works very similar. So I'm just choosing option 2. I copy this order ID, enter it here, confirm the deletion, and now the application deletes the order again. Again, we can verify this in Excel by refreshing here, and now we expect that the last entry disappears, and yep, the record was successfully deleted. Okay, so now we have seen how it works from, let's say, an end user perspective. Now the interesting question is, how does it look like in C# code? So let's check the create order method here. The first thing we do regarding to all the ODBC stuff is to open the ODBC connection. And for that, we are building a so-called connection string, which basically consists of DSN, user ID, password, and the DSN is actually the data source name I just showed you in the data source administrator here. In my case, all this information is read from a config file and concatenated together to have this connection string. Based on this connection, we then create a ODBC command, this line, which basically represents the SQL statement to be executed. For the order creation, for sure, it's a simple insert statement to our Devtober order entity. And as you know, we have here 4 fields. The first one is the order ID. The second one is the creation timestamp. The third one is the beer amount. And the fourth one is the food amount. For generating the order ID, I'm using a second SQL statement on the same connection. And it's just a select statement, which is using the built-in function UUID and the dummy entity available. So with that, we're just retrieving a UUID from the database, and together with the input values, so together with the beer order amount and the food order amount, we are bind all these parameters to the statement before executing it in this line finally. Yeah, and one important point to mention here is that the SQL service is currently always in an auto commit mode. So we do not have to explicitly commit a transaction here because the SQL service implicitly commits after a statement was executed. The deletion works in a similar way. For that, let's check the delete order method here. Again, we are opening the ODBC connection by passing the connection string. And instead of the insert SQL statement, we are now using the delete statement on our order entity with a simple where condition on the order ID. Yeah, and that's basically with the first part of new features. So it's new to insert and delete records for SQL services. And now you may remember the third option in my simple application here. And let's see what it offers. So I run the application again. Now it's somehow I clear the console again to have it nicely rendered. So now I'm choosing option 3. And now the application asks for a low year filter. So we can now specify a range-based filter on the year. Let's say we are interested for the years 2022 to 2023, for example. And then it asks again for some input order amount adjustment, let's say 10. It's not that important what the semantic of this field is actually. Now I'm executing it, and now it shows up 2 results. First, it prints all the results available for all years available in the system in an aggregated manner. So for the year 2022, 2023, and 2024. And then it prints all the filtered results based on our filter. So all the years, but not the year 2024. And to do that, I will switch back to ADT. I have implemented a ABAP-managed database procedure, and let me show you this in the service definition first. It's now about the second line. Here you can see I'm exposing a method, and again I'm using an alias name. And this method, if I navigate forward to the implementation, we can see that it's implemented by an ABAP-managed database procedure by using the SQL script language. If we have a look for the signature of the method, then we can see that it takes two input parameters. The first one is a table-like input parameter. So if I navigate forward to this type, then we can see that's a table type in the dictionary. And it's basically, as I said, a table type with the year range, and it's basically a standard table with an empty key. The second input parameter is this sum adjustment value. We just where we just put in the value 10, and then we can see that we have two exporting parameters, and both of them are typed by a table type. And that's basically all. But one important thing is also this addition here for SQL service. This addition allows us to expose this method via an SQL service. Without this addition, it's not possible to expose it in a service definition. And for sure, this addition enables some restrictions to the method here. Okay, I think we can have a short look on the implementation too, but I think it's not that interesting at this point. It just reuses another MDP method and then adds this sum adjustment value and applies this year range filter. So let's check the service binding again, because here we must enable the operation execute to allow the execution of procedures exposed in our SQL service. And furthermore, in the communication scenario, we must add the authorization object as SQL proc, as we did for SQL view as well. So if I open it here, we can see I also used a wildcard, and we allow operation execute for all procedures exposed in our SQL service. Now let's see how to use it in the C# code. And that I scroll a bit down, and now we can see the method summarize result. Again, we are opening a ODBC connection, and to fill the input table parameter, we need some kind of, let's say helper construct. We need to use a local temporary table, and this local temporary table can be created by using the create table statement as shown here. So we basically create a local temporary table with name table ranges, and this table has two columns. First one with the name low and the second one with the name high. Both are typed by int4. So these local temporary tables are bound to the connection where they were created on, and their lifetime is bound to the lifetime of this connection. So as soon as the connection is closed, this temporary table is destroyed as well. You can then insert data into this table, and of course you can also read or delete data in it. And a temporary table can be deleted completely by using the statement drop table. So we could write drop table and then the name of the local temporary table to completely drop the table. Okay, so the procedure itself is then called by the call statement in this line. And the temporary table we just created and filled with data is passed to the input table parameter just by naming it here as an actual parameter. And the scalar input parameter is bound just like we did earlier with insert and delete. So by specifying this quotation mark here and adding it to the parameters list here. And then we have the two exporting parameters. And for the two result tables here, we just specified that we expect them as result sets. And that's an interesting point because for a procedure call, we can have multiple result sets. And that's really one important difference to, let's say, ad hoc select statements. Yeah, and other benefits of procedures are that they can have table input parameters, as we can see here. And they allow us basically to keep all the business logic in the ABAP system. So we do not need to move all our business logic, which could be complex SQL logic, to the client-side application. Instead, we can keep it in the ABAP system and implement it there by ABAP-managed database procedures. Yeah, and then the command with the call statement is finally executed, and both result sets are printed to the console. And after we finished the first result set, we just switch to the next result set and write it to the console as well. Yeah, with that, I'm already at the end and provided an overview about the current capabilities of SQL services. And that, let me quickly go back to the presentation. And with that, yeah, we are coming to an end. For sure, in general, we only showed an overview about data integration in ABAP Cloud. If you would like to learn more about it, I really recommend to check out the available documentation and all the other resources available. And in this regard, I also would like to highlight the link on this slide. There you can find some blog posts about SQL services, providing some more practical hands-on and examples. With that, thank you for your attention, and back to you, Shilpa.
Thank you, Yannick and Lian, for a very wonderful session. I really liked how we can connect data either from Excel or the other systems. We do have one question. Um, are SQL services an alternative to OData? What is the purpose of SQL servers compared to OData? Is it to make it ODBC compatible?
That's actually a good question. So I would say it depends on the scenario. So in general, the SQL services, from my perspective, are more for a technical integration of data. So you have to decide if you need some end user application which is accessing the data, or if you just would like to integrate the data in a technical manner. So it depends on the concrete scenario. So it's not a replacement, it's just an addition to the existing OData service binding.
Yeah, thank you, Leon. Maybe we can wait for a minute or so to see if we can get if we get any other questions. Okay, I don't see any more questions in the chat. So with that, thank you, Leon, for addressing this question. Yeah, thanks to both of you for taking some time and giving this session. For those of you watching replay, and if you still have any questions, you can put as a comment in the community page. The link to the presentation will be put up in the description. So thanks for joining, and see you in the next session.
Goodbye.
Goodbye.